Okay, in this example, I'm going to do example 24.4 on page 453 in the Chemistry Live book. It's a Stoichiometry II, and the question reads, a sample of ethanol, which is here, was prepared by reacting, a sample of ethanol was prepared by reacting ethanol with sodium dichromate, a mass of 14.9 grams of sodium dichromate. So first of all, I'm going to put that in underneath the dichromate in my balanced equation, and 11.5 centimeters cubed of ethanol, 0.8 grams per centimeters cubed were used. So I'm going to write that in as well. Now it's given me a volume in centimeters cubed, and it's given me a density of 0.8 grams per centimeters cubed. It's told you that it was found that 1.6 grams of ethanol was formed, and it's given you the balanced equation. So first thing that I'd notice here is the balanced equation. If you look at ethanol to dichromate, it's in a 3:1 ratio. If you look at ethanol to ethanol, it's in a 1:1 ratio because it's 3:3. If you look at dichromate to ethanol, it's in a 1:3 ratio. So like always, the first thing I need to do is identify out of all my reactants which one is the limiting reagent, because obviously once the limiting reagent is used up, no more product can be produced. On the left hand side, the two main reactants I have are ethanol and dichromate. So I'm given ethanol in centimeters cubed and density, and all I care about is moles. I'm given dichromate in grams, all I care about is moles. So the first thing I'm going to do is convert all of these into moles and then identify which one is in a limiting amount. So let's see, right. Density here, if we don't remember from junior cycle science, is mass divided by volume. I've been given the density as 0.8 and I've been given a volume as 11.5 centimeters cubed. What I want to find is the mass. So in order to get the mass, I'm going to rejig this equation and multiply the density by the volume. Okay, when I do that, that's going to be 0.8 multiplied by 11.5 centimeters cubed. And I'm going to get a mass of 9.2 grams. So what I actually have here is 9.2 grams of ethanol and 14.5 grams of sodium dichromate. Still, that is no good to me. What I want everything in is moles. Okay, so moles is mass divided by relative molecular mass. Now, first one I'm going to do is ethanol, which is C2H5OH. In your exam questions, you have to write out where you got the relative molecular mass. So from the periodic table, you're going to take 2 times the mass of carbon, plus 5 times the mass of hydrogen, plus 1 times the mass of oxygen, plus 1 times the mass of hydrogen. So it's 2 times 12 grams, plus 5 times 1 gram, plus 16 grams, plus 1 gram will give you a total relative molecular mass of 46 grams. Moles of ethanol then are going to be the mass given to you, which is 9.2 grams by 46. And you get 0.2 moles of ethanol reacting here. At this stage, what I would always do is go back up and write that underneath the balanced equation so you don't forget what that amount is. The second thing I'm trying to find is sodium dichromate. Now this is really important. Sodium dichromate in the balanced equation is just given to me as the dichromate ion because this is quite a long equation, and usually in chemistry, if there's any shortcut to be taken, we'll take it. So what they've done here is just given you the skeletal version of the balanced equation. These H+ ions here are just indicating acidic conditions. We don't know what the acid is, etc., etc. So sodium dichromate is not given to me there, but in the book down here, they've given you sodium dichromate as the full relative molecular mass. In an exam question, they will always give you the full molecular formula written out like this, and it will always be in bold, and if it's in bold, that means you absolutely need to use it. So I'm going to write out the full name for sodium dichromate here. It's Na2CR2O7.2 times H2O. So unfortunately, you do need to figure out the entire molecular mass using the periodic table of this. And this is often a space where students make lots of slips, so we have to be very careful here. It's going to be 2 times the 23 grams of sodium plus 2 times the 56 grams of chromium, nope, the 52 grams of chromium even, plus 7 times the 16 grams of oxygen, plus, and then we know that in chemistry this dot here means plus, so it's 2 times 18 grams, which is all of water. And when you add all them up together in your calculator, you'll get 289 grams as being the relative molecular mass. So the moles is the mass divided by the relative molecular mass of sodium dichromate. The mass given to me was 14.9 grams. The relative molecular mass is 298 grams. That gives me a number of moles as 0.05 moles of dichromate. Again, using a different colour pen, I'm going to go back up here, 0.05 moles. Now that I've converted everything into moles, it's very easy to see from the balanced equation. I reacted 0.2 moles of ethanol with 0.05 moles of sodium dichromate. It's very clear to see here, ethanol is in excess, sodium dichromate is my limiting reagent. So in order to answer part 1 of the question, I'd write down here, ethanol is in excess, because that's what the question was asking you. However, the only part that's actually important to you is that the sodium dichromate is in a limiting amount. Why is that important? Because when the sodium dichromate, 0.05 moles of it is used up, no more ethanol can be produced. Once we've run out of one of our reactants, there's no possible way any more product can be produced there. So what that means for us is I need to see if 0.05 moles of sodium dichromate are used up, theoretically, how much ethanol will that produce? So just to make a little bit more space, I'm going to go down here on the page. Okay, so we have sodium dichromate, which is Cr2O7 minus to 3 ethanols. Okay, they're in a 1:3 ratio. How do I know that? Because there's nothing in front of dichromate and there's 3 ethanols. How much sodium dichromate do I have reacting is 0.05 moles. That means I'm going to have 3 times that amount of ethanol produced, which is of course 0.15 moles of ethanol being produced in an ideal world. That would theoretically be the maximum amount of ethanol I could produce. The second part of this question actually asked me to calculate the percentage yield of ethanol. So in order to calculate the percentage yield, I need the actual yield produced divided by a theoretical yield multiplied by 100. So the actual yield produced here, I need to work out from this value. So mass is equal to moles multiplied by relative molecular mass. In an ideal world, the maximum number of moles I could produce is 0.15. The relative molecular mass of ethanol from the periodic table is going to be 12 grams plus 3 grams plus 12 plus 1 plus 16, which works out at 44 grams. So 0.15 by 44 grams will give me 6.6 grams of ethanol as being the theoretical yield. From the question, they told me 1.6 grams of ethanol was all that was produced, which seems quite poor considering before the student carried out this experiment, they were expecting to yield 6.6 grams. So now I'm just going to work out the percentage yield, which is 1.6 divided by 6.6 multiplied by 100, and you get a percentage yield of 24.24%, which is quite a poor result in that experiment.